Good morning. We are Team Labyrinth, presenting on our project Identify for the EMPath 2020 Virtual Makeathon. With special thanks for our mentor Ahmed, my name is Jacob Urbina.
Hi, I'm Cassie.
I'm Norhan from the University Egypt.
I'm Minna. I'm sorry for not opening my camera, but my Wi-Fi connection is so low.
So to begin, fall is right around the corner, which means schools are starting to open again and students are about to get back into classes. With many parents starting to go back into their jobs, the kind of commuter overlap is going to be very difficult, meaning some children will have to take the subway. On this particular fall, a mother is trying to teach her child how to take the subway. She bought the tickets, she's teaching all the stops and locations, she's making sure that they know exactly where to go so that whenever the time's right, everything is perfect. However, unbeknownst to this mother, the first day, there's a commuter on the subway that has just evaded the fare. Without any proper documentation of proof of purchase or knowing that a customer and commuter is on there, they have no way of actually verifying who they are, where they are, and it poses an incredible security risk and incredible liability for transportation companies. For these transportation companies, loss of profits on top of the evaded fare, on top of security and the liabilities, are all increasingly detrimental to trust of the commuter and customer bases. And due to the coronavirus pandemic, these companies have started to severely limit their in-person security officers. This means an increase in fare evasion and a decrease in customer trust, meaning that already on a weaker market due to less people going on the trains and any types of public transportation, we're already suffering a major loss. So our goals are as follows. We want to provide a way to have personal authentication from the user that says, I am who I say I am purchasing this ticket. And once they purchase the ticket, they will then move forward and have that authentication inside the train station or the bus station. We also aim to have a secure database that allows for standardization and privacy through all modes of transportation. For instance, this wasn't just a story on subway transportation. My own team member, Mena, her brother was involved in a fare evasion conflict while riding the bus. He had his ticket, he goes to his seat only to find someone else, and it posed a very dangerous situation that could have ended incredibly badly. Lastly, we want to have a comprehensive image data set that allows for variability in understanding who our customers are and allowing for, or who the commuters are, so that the transportation companies know that they are who they say they are. Our solution is as follows.
So imagine you're ordering your ticket online. On the online checkout process, we simply add an additional feature where it uses the webcam that you can find on any computer these days or your phone, and you take like 10 to 15 pictures of yourself. And this gets sent to a secure database where your face gets scanned with Identify. And then when you're boarding whatever public transportation you bought a ticket for, you check that face with the database. It'll be a similar interface where you have your webcam again. And it doesn't even need to be a high quality photo, and it does a face ID match just to make sure, just to address these problems that Jacob just brought up. So mostly we're taking the two-prong approach. One, this ensures the security and safety of passengers and consumers who are boarding these public transportation services. And then as for the transportation side, they're saving a lot of money so that they don't have to face fare evasion. So in New York City alone, they face $240 million per year loss due to fare evasion. So now I will be live demoing our product. Sorry. So this app was created with React.js and using the Material UI library. So as you can see, this is a very stereotypical checkout page. You have your shipping address, your payment details, and you see we've added a third step, Face ID verification. So you can see the webcam shows up. You take a few pictures, and you just take like 15, and then you go to next step. You're done. It's a very simple, streamlined process. There's nothing super extra, so this will integrate very easily with current checkout processes. And so, again, our app. Our app is a React.js front end with a material using like the material UI library, and this data is then passed to a MongoDB database, which Mena will now explain.
So as Cassie mentioned, we use the MongoDB as our database, and I'll now explain what is our database architecture. We have two main entities. First, users, of course, they have the main attributes of ID, username, email, password, and the images that they will take while putting the packets. And the other entity is, of course, the vehicles themselves, and their main attributes are the ID, trip details, and a list or array of the IDs of the allowed passengers who booked the taxi. Moving on to our facial recognition model, we used first pre-trained her face to detect that there is a face in the image. Second, we used the local binary pattern histogram to do our face identification task on the images that are on the our database. In our project, for simplicity, we trained on three main people only. We used Lana Del Rey, Taylor Swift, and myself, my photos. Then after we train our model, we save the weights. Here comes the third part, which is the production in the car itself or the vehicle itself, where the model can predict the person and the confidence level. However, I need to mention that confidence level here means that it's the opposite of similarity. So higher confidence means that the model is not so sure about the identified person. The higher, the worse. The lower confidence is the better. Here is a demo to explain what we did. So first, we load the model and then input a photo of Lana Del Rey. Here is a confidence level 29, which is low. So it's okay. We trusted that this is Lana Del Rey. After that, we uploaded a photo of Taylor Swift. It's okay. It's about 40. Still so low. Then we tested it in a photo of me. Predicted correctly, Minna was like 40 confidence. However, when we input like a fourth image of someone who doesn't know, the model doesn't know, it predicted it with so high confidence, 93. So we can conclude that it's not in our database. It's an unknown person. After that, when the prediction is done, we can check if the person is in the allowed list or not. Moving on, Nurhan will talk about the business context of our project.
Okay, moving to the business part. Since we are working on a product that needs to be a startup or a real product, finance product in the future, so we worked on the BMC, the business model canvas, in order to gather from where we're getting our revenue stream, who are our customers, and the relationship with our customers. Slide next. So we will be our customers. The customer profile, we are a service B2C. So we are targeting two types of customer: transportation companies that need to secure their technical process, and the car owners that needs to secure their cars from theft and getting robbed. Okay. The value proposition. What value we are adding to the market? Identifies a facial identification service that registers user face in the database while buying a ticket, as Cassie showed. and receives the image again when the user is boarding to the bus and car. So the company can make sure that this is the user who registered for ticket. So the three values we're adding, the main values that we're adding to the market is secure ticketing process, secure owned cars, avoid money losses due to riding the bus without buying a ticket before. From where we are getting our revenue stream, from two main things: service subscription fees that we get from selling the service to users or transportation companies, and as well as advertising for cars and bus manufacturing companies that we are making in our website or in our service. Who will be our key partners? Surely we will be having many key partners, but for now, the main key partners we're having the stores for car and passports that we can recommend users to buy their spare parts from them. Okay. Since we are not alone in the market, we have competitors. We have direct competitors and indirect competitors. The direct competitor is Telbo, a service called Telbo TBS 980, a service used in public transportation in China, and it's used in facial recognition. It's kind of similar to us, but less secure, and the accuracy is not that high. The indirect competitors that use facial recognition, but in other services, not just transportation or securing ticketing process like us, is FineFace, Amazon's recognition, and Facebook's deepface. How we can get into the market to let people know about us? This is our market penetration process. We can get into the market through posts in car competition and bus stations. We know there are many car races that can be held in each country, so we can make posts there to let people know about our service. Free download for the app or the service, free subscription for a trial amount, a duration as a trial, social media campaigns and ads. Okay, how we can reach the user, the channel that can user reach us through website, social media, app store, and Google Play. What we are planning to do in the future, since we will not be stopping here, we are planning for both things, for two main things: facial authentication under a mask. Why it's important? Because at the pandemic, like what we have experienced recently during coronavirus, many people are wearing face masks. So how we can identify these people? That's what we are working on, to identify people even if they are wearing a face mask. One more thing is ride-share service. To illustrate more, if I'm having a car and I'm allowing people to join me in a ride-share service, so I need to make sure who are these people. I need to identify them. I need to, like, the people who are registering through the app of ride-share, I need to see them again. So face identification is very important in car identification service, to make sure that the people who are registered for this service or ride-share service is the people who are really taking the car with me. Okay. This is our project identify, and thank you, Fativa. Thank you everyone for listening. Any questions?
All right, thank you very much. Okay, so I have a couple questions.
Okay.
So it's more of a clarifying question. So you mentioned at the beginning it's like a subway story. Are you thinking, I'm thinking we're in Boston and we just have like these little cards. We don't have to produce ID or anything to buy anything for the subway. Were you thinking of this like when you go online and buy a ticket for like a cross-country bus trip? Is that more what you were thinking versus the subway?
So I can take this question. I think this is more aimed to like for any public transportation. So when you're going on the subway too, there will be like a little webcam scanner, and it checks if you're the right person with the ticket.
Okay, so that goes into my second question. So on the subway's side, how would they enforce this? Or like, so for every trip, do they walk in and there's like a scan of every person coming in, or is it like a shot of the bus or whatever, or how does that look?
Yeah, there would be a user profile for every single person who purchased the ticket. So if you're, for example, a mom who purchased the ticket for her kids too, you would have to scan their tickets too.
Okay. And then my last question was for the demo, you said take 15 pictures. It seems like a lot of pictures. Have we thought of reducing those pictures, or like doing a video, or just more of a logistical comment?
Mena, would you like to comment on this one?
Actually, the idea of having more photos is for our model to be better. The more photos is the better. However, I got your point that it's not easy for the customer to upload photos. So in the future, we can make the user just upload photos from his PCs. You know, he doesn't have to like take a photo for a talk. Take 15 photos.
It can also be a video, like a small video, 30 seconds or 1 minute, that can be that from where the camera can take many shots in 30 seconds
Yes.
or 1 minute.
Yes.
Cool. Okay. Mike or AJ, do you have questions?
Yeah, this is a definitely a needed product, as there's lots of thieves out there. So how would you react to someone, you know, given the privacy versus safety trade-off, if you could just use your phone instead and not have to give your photo? And so maybe you had a either, you know, electronic payment or some system that would recognize who you are without having to take your photo, given all the privacy issues that people have had.
You're talking about the privacy, like how we can secure the privacy of the user, the registering user.
Or in terms of your competition, so maybe a competitor says we can do the same thing, but we don't need to take people's photos.
Actually, it's okay. I know that people talk privacy, but when it comes to the company, the transportation company, it's really crucial to know who the user is registering in the bus. So in the future, we can consider adding more biometric process like the fingerprint of the person, or any other thing that we can identify this person other than the camera. So in the future, we can add more process. If you don't like to add your photo through the camera, so add your fingerprint. If it's easily accessible for you to add your fingerprint to the application or the website. But in post situation, I know it's a privacy issue, maybe a privacy issue, but the company needs to make sure that this is the person who registered for ticket to take the ticket. Not just anyone took the ticket and rode into the bus.
Okay, thank you. Mike, over to you. I think you're on mute still.
Thanks, AJ. That's the third time AJ's helped me with that in the last 24 hours. So thank you, AJ. So I know you mentioned you know, the kind of the challenges with like masks and starting to compound these things. You know, if somebody's wearing a hat and the mask and sunglasses, or you know, all of these compounded things you wear on a you know, potentially public transit, and especially in the current era that we live in. You know, how do you see being able to be robust around that, and then kind of what's like the backup system for when that inevitably fails?
So I know, like, as of right now, retina scanning is also coming of age. So again, like with the mask, this would be a really great alternative. Again, Norhan mentioned there is the possibility of using a fingerprint scanner. I think those are good workarounds.
We're just wanting to make sure that the company don't lose any money on tickets that, like, the people are stealing or people are taking seats in the bus without buying a ticket before. So we are trying to consider every aspect that can guarantee that can guarantee the safety and or guarantee the money. No, there's no money lost for the company. So for now, we consider the computer vision and face recognition. In the future, we can consider more biometric sensors.
Cool. Anything else? You good, Mike?
Yeah, I'm good. Yeah, thank you.
All right. Awesome.
Thank you.
Okay. Thank you, everyone. Give us a minute to fill out our forms. And
Thank
next
you, everyone.
up, thank you. And next up, we have innovators. I'm sorry, I totally butchered that. But if you guys want to get set up, get ready, share your screen, and we'll be right back.